Hello students, welcome back to my physics channel. In this video I am going to discuss about motional EMF second part. See, actually you know guys very well what is motional EMF. Because of moving of any current carrying conductor, it will induces some EMF inside, that is called as motional EMF, students. So any rod which is carrying current here, it has to move inside the magnetic field, or else in the presence of magnetic field it will create some current, that is called as motional EMF. Already we have discussed. Did you remember the formula for motional EMF, students? Yes, that is the last formula. You can see in the last video I have posted motional EMF 1 part 1. In that you will be understanding that how the EMF will be produced in the circle, I mean to say in the loop. So because of the current carrying rod movement, isn't it? So that formula I will give you the information regarding that. EMF is given by, that means motional EMF is given by BLV we got. This is what the final equation we got here, students. See, for your kind information, we need to know one thing here. L is a vector, B is a vector, V is also vector. I will tell you the shortcut how to remember this. Please listen carefully. So any EMF, you know one thing, students, EMF is always scalar quantity, student. It doesn't have any direction, but current has a direction, but it is comes under scalar quantity only. So you should understand one thing, current is not a scalar, not a vector, it is tensor of course. So it is not required now. See, what I am telling here is EMF is a scalar quantity here. It is the product of three variables. What are there? Magnetic field, length and velocity also. So for a kind information, direct formula I will tell you for EMF. Write down that formula, students, make it first. That is L bar dot B bar cross V bar. I am sorry, V bar cross B bar, students. Remember this formula? Remember this formula, students? Yes, students. So EMF in a sense scalar quantity, L bar, V bar cross B bar. See, you guys know very well, V bar cross V bar is a vector quantity. That is VB sin theta. Already we have discussed in the case of many times we have discussed. V is the velocity, B is the magnetic field, fine. L is the length, that is also vector here if you are considering. Then finally we can say this is called as vector triple product, students. Vector triple product. What do you mean by vector triple product here? We are doing two kinds of multiplication at a time. See, cross product we are doing, dot product also we are doing. First we need to do cross product, then we will get one vector. That vector will be multiplied for L as the dot product, then you will be getting EMF. So anyhow, dot of these two will give scalar only, because dot product of two vectors always scalar only, because it is a scalar product. Try to catch my point. So now, in the case of magnitude, if at all I want magnitude, this is a vector form, student. This is a vector form. This is a vector form. Please remember this. EMF vector form is equals to L bar dot V bar cross B bar. Or else you can take V bar cross B bar into, this can be written as like this also we can write. V bar cross B bar dot L bar also you can write. There is no issues. Dot product A dot B is equal to B dot A. Fine. Coming to EMF is equals to, if you are taking magnitude of this EMF, then how can you do this? That is very simple. L bar, okay, L, the magnitude of L bar is L. And then coming to V cross B in a sense VB sin theta. Students, are you understanding? So finally you will be getting LVV sin theta, students. This is what EMF. This is what EMF. Students, make a note of this. It's a very important formula where theta is an angle between. Can you tell me what is the theta here? Theta is an angle between. Tell me first. V bar and V bar. Very good. V bar and B bar, student. Very, very important point it is. Make a note of this, students. Next, I'll go for one more application. Yeah, make a note of this. Okay, fine. So EMF, final EMF formula is LVB sin theta, where theta is 100% angle between V bar and B bar. There is no relation between theta and L. So do not forget about this, students. So L bar, it doesn't L bar we are not taking in the consideration of theta here. Okay, fine. So let me go for application of this. Okay, fine. This is what called as motional EMF. By the movement of any rod we will be getting EMF, that is why we will call it as motional EMF, students. Okay, fine. So let me go with one more explanation. If the rod is in a circular motion, so how come the rod will be in the circular motion? Students, make a note of this. Let me consider this is a uniform magnetic field here, and let me consider I have a rod here. Let me consider this is my rod. Okay, current carrying rod. Let me consider one point is fixed here. Another tip of this rod is supposed to move here like this. Definitely, it will create a circular motion. Am I right, students? Make a note of this. Okay, fine. When it is started moving like this, definitely it will be at rest. It will be at rest point O. This point A will be here. Then definitely, does it produce any EMF now? Let us see that. That EMF, how can you find it? Okay, fine. So I hope you are understanding this task here. Let me consider the total radius of this is nothing but R. R is the length of the rod, you can say, no problem here. So L also you can take, no problem. Better you can take L. So one tip is moving, another tip is at rest. Then it will create an EMF. How it is going to create an EMF? That's what we will see, students, now. Okay, fine. First, let me consider it is at rest. This tip is moving. Let me consider the rod. The rod is here. Fine. The rod whose length is L, capital L. Let me consider one dx part of this rod I am going to take. It is at rest. This is at rest. It is started to move. So let me consider it is moving with v velocity. This dx is moving velocity. So that dx will make a circular path. Circular path also. So let me consider the distance between the center to this dx is x. Okay. So a small dx in a sense is very least elementary length of the, this is what dx, students. Elementary length of the rod you can take here. Now it has started to move perpendicular to the magnetic field. See, this magnetic field is inward magnetic field. Already you know this very well. Inward magnetic field we are taking here. Now, if at all you want to find the EMF generated, you know the formula. What is that? Motional EMF. So dE is equals to, why we have to take dE? EMF. Students, dE. So dE is equals to, so small e is equals to, what is that? B L V, isn't it? So instead of L, we have to take dx. Why? Because small part, this part alone moving we have to consider. Because tangentially it will start moving now in the circular motion. That's why. So now we can get dE is equals to BV into L means dx. Any doubts, students, here? Any doubts on this? I don't think you have doubt here. Yes, BV dx. BV dx in essence, how can you do BV dx here? So B is there, V is there, dx is there. Fine. Fine. Do you know what is the velocity of this when it is moving like this? Let it be a radius. It is a radius means x here, right? Okay. It is moving like this now. So what will be the velocity? V is equals to, what is the formula, you tell me, students? What is the formula for velocity? V is equals to R omega. R omega. In the same way, the velocity will be equals to, R means x here. X is the radius of this dx. So R x into omega means omega you can write. So instead of V, we can take omega here, students. See, wherever you may take, omega is constant. That is why omega is constant here. So in the circular motion, omega is constant, students. Why? Because omega means angle change. Wherever on the rod you can take a point, there all omega is same. Try to catch my point. So dE is equals to B in a sense same, V in a sense x omega into dx, students. Any doubts up to here? Any doubts up to here? So let me consider what happens to this value. So now dE in a sense, we want EMF, right? We have to do integration process for this. So if at all doing integration, what happens here? Integration of dE is nothing but E, EMF. Now B in a sense constant, it will come outside. So omega is also constant, it will come outside. Okay, omega is also constant, it will come outside. I told you clearly omega is constant, students. When any rod started to move here in this circular motion, this tip is moving, this tip is moving, wherever the pot is moving, the omega is constant here. But velocity will be changes, tangential velocity will be changes. So this tangential velocity v1, this tangential velocity v2, this tangential velocity v3. So these are different. V1 is greater. Why? Because radius is more. Whose radius is more, that V value is more. But omega is constant everywhere. That's why I take omega is constant, I send outside. So now x dx we can write inside, students. Any doubts here? X dx means what is the answer for integration of x dx, you know? So EMF is equals to b omega into x dx means x square by 2. What do you mean by this x value? X value will start from 0 to L. Try to catch my point. Here you can take dx, here you can take dx, here wherever you are taking dx, the distance between O to that dx is x. So up to where it will increase? 0 to L. So that's why you can take here 0 to L is the limit. 0 to L is the limit. This x value. Okay, fine. Now we can use the 0 to L limit. So now EMF is equals to b omega L square by 2 is the answer. That's it. Very, very important derivation. So EMF generated in the case of whenever the rod is moving in a circular motion, then the EMF is given by 1 by 2 b omega L square is the answer, students. Make a note of this. Make a note of this.